Our lectures so far this quarter have been leading us to this point. Today is the day that we start learning about algebra. But first, let's talk about where the word algebra comes from. The word algebra comes from the Arabic word al-jabr, which means the reunion of broken parts. The earliest reference to algebra is in a book written around 820 AD by a mathematician in Baghdad. And the book was called the Book of Calculation by Completion and Balancing. And this is going to be important as we learn these notes today. A modern definition of algebra is a branch of mathematics that uses symbols such as x, y, or even a diamond in place of unknown values. We call the symbols variables. So these symbols right here that are not numbers are called variables. Can you think of any more variables that might appear in an algebra problem? Write them here. Maybe throughout your math schooling, what other variables have you seen in any problems? You might have seen an n, maybe if you took Math 4 here, when you're trying to solve for a proportion, that's a variable. If anybody learned anything about geometry or the Pythagorean theorem, you might have learned A or B or C. These are all variables which stand for numbers that you're trying to find. So let's talk about how algebra is different from arithmetic. Algebra uses symbols or letters to stand for unknown numbers, excuse me, like we just saw up here. But in arithmetic, all the numbers are known real numbers. So look at some examples and decide if it's algebra or arithmetic. 12 divided by 6 equals 2. Do you have to solve for anything here? No, you know you have a 12, you know you have a 6, you know you have a 2. So this is going to be arithmetic. You're not solving for anything. Let's try the next one. 5 plus x equals 7. Well, you know you have a 5 and a 7, but you don't know what the x stands for. And this is an example of algebra. And the last one here, 23 minus 1/2 equals 22 1/2. You have your numbers here, 23, subtracting 1/2, and then you have your answer. Of course, you might not like working with a fraction, but it's still solvable, and you know the numbers, so it's arithmetic. Maybe if there was an x in place of the half there, that would be algebra. So remember that the first book ever written about algebra talked about balancing equations. When we solve algebra problems, we are going to balance each side of the equation. I don't know if you've ever seen something like this before, an old-fashioned scale or balance. We're going to look at this for just a second. I think it will help us understand the process here. So for example, in the equation, x plus 4 equals 5. The value on the left of the equal sign here, this value here, must be the same as the value on the right side of the equal sign. So let's go ahead and put some numbers here. On the left, and let's call this, the middle of the balance here will be the equal sign. So on the left, we need to have an x, and we need to have a 4. And on the right, we need to have a 5. To make your balance even or equal and not tilt to one side or the other, all of the numbers on this side must equal 5. So here we have a 4 and some other number. When you add them together, you must get 5. So what do you think that x should be? Luckily, we're doing an easy one first, right? It's going to be 1, because a 1 plus a 4 is 5, and I have a 5 over there. So x must equal 1, so both sides are balanced. Now let's look at the equation x plus 3 equals 15. And let's just do the same thing. Let me grab my little numbers. On one side, we'll have an x. On one side, we'll have a 3. That's the left of my equal sign here. Now on the right of my equal sign, I need to have a 15. So the numbers are getting a little bit bigger here, but it's still the same process. I have a 3. Whatever number this is, both of those together must equal 15. So you can actually do this part in your head. What do you think the x will be? Must be 12. Because 12 plus the 3 will be 15 on this side. And I have 15 on the right. So my scale will be balanced. So the x would be 12. And there, you just did algebra. Of course, that was a little easy, and we did it in our head. But for the rest of the lecture today and the rest of our classes, you need to work the problem out on paper because they will be getting much tougher, and sometimes our students like to do them in their head, but then they end up getting stuck once we get to 2-step and 3-step algebra problems. But today, we're going to learn simple rules for adding and subtracting algebra equations. So let's do addition first. First, you have to look at what operation is being done. If the problem is addition, if you see a plus sign, then you will do the opposite and subtract. Addition and subtraction are paired up together in algebra, and so are division and multiplication. So today we'll work on these. Subtract the number from each side of the equation that will leave the variable by itself. And here's what I mean. X plus 4 equals 10. If we were doing the balance that we did up above, you might say, well, I know these two numbers must equal 10, so this has got to be 6. And that is true, but let's see how we proved it. You have to start working them out. I see addition, so I want to do the opposite, which is to subtract. I'm going to subtract 4. And it says you have to do the same thing on each side. Don't forget that if I subtract 4 on this side, I must also subtract 4 on this side. And here I've shown you in purple. You're subtracting 4 on the left side of the equal sign, and you're subtracting 4 on the right side of the equal sign. As long as you're doing the same thing to each side of your equation, you're not changing the value of x because you've balanced it. You can take off 4 apples on one side of your scale, take off 4 apples on the other side of your scale, and it's going to be balanced. And then when you work this out, you would say, oh, plus 4 and minus 4, those are going to cancel. On this left side, I just have x all by itself. And 10 minus 4, on this side, I have 6. So what does x equal? It equals 6, and here's how you've proven it. Next page. Now we're going to try to balance some equations using that step there. You look and you see what operation do I have, and I have addition, so I'm going to do the opposite and subtract 7. But remember to do the same thing to each side, otherwise you're not going to be solving correctly. You must balance the equation. There, I took 7 apples off of each side. The reason that we're doing that this way is because, plus 7 minus 7, I get to cancel these out. That's going to just be 0. So on the left side of my equal sign, I'm going to have x by itself equals 19 minus 7, 12. And I just solved the problem. Let's try the next one. X plus 2 equals 30. Of course, in your head, you might say, I know that's 28. I don't even need to solve it. But you do. You have to get used to this and start practicing. This is addition. Do the opposite and subtract. What number am I going to subtract? This one here that's right next to the x, because I want to get rid of it. Remember, the goal is to have x by itself, and I can do that if I subtract 2 right there. Those will cancel out and become 0. But don't forget the next part, which is to subtract 2 from each side. There we go. From each side of my equal sign, which is right here. So these are canceled out. Plus 2 and minus 2, that's 0. X is left by itself. 30 minus 2 is 28. So even though I knew the answer was 28, I have just proven it. Ah, here we have a decimal. Don't be scared, it's the exact same thing. You have addition next to your x, so subtract. And pick the number that's right over here next to your x, 1.5. Subtract 1.5 from each side to keep it balanced. These will cancel, and I have x all by itself on the left of the equal sign. And on the right should be my answer. 4.5 minus 1.5 is 3. Now let's talk about subtraction. You might be able to guess how we're going to do this. If the problem is subtraction, do the opposite and add. Add the number to each side of the equation that will leave the variable by itself. So here's your example. You look at this simple algebra problem and you say, aha, I have subtraction. I know I'm supposed to do the opposite then and add. But what am I adding? You always pick the number that's over here on the left side in this term next to the x. Just take the opposite. It says -5, now do a +5. And do the same thing to each side. And here I've shown you in purple. You're just adding 5 to each side to keep it in balance. So then I can cancel these out. +5 and -5 is just 0. So x is all by itself on the left side of the equal sign. 6 plus 5, 11. X equals 11. And here's a hint. Always plug the answer back into the equation to check yourself. So if I think the answer is 11, just plug it back in. Plug it back into the original problem. X minus 5 equals 6. Instead of the x, if I put 11, let's read it and see if it makes sense. 11 minus 5 equals 6. And yes, it does. So I know I have the right answer. Now try balancing these subtraction problems on your own. I see a simple algebra problem, and I see subtraction. I'm going to do the opposite of that and add 14 to each side. Cancel out a positive and a -14, which was the whole goal. And I have x by itself on the left equals 3 plus 14, 17. And I could plug that back in. 17 minus 14, yes, it does equal 3. How about x minus 3 equals 20? You look at the algebra problem and you see a subtraction in the term with the x, so you do the opposite and you add. Add 3 to each side. These will cancel, -3 and +3. That leaves me with just an x all by itself on the left of the equal sign. 20 plus 3, 23. Let's plug it back in. 23 minus 3, yes, it is 20. Good. Last one on this page. X minus 4.5 equals 5. So this is subtraction. Do the opposite and add 4.5 to each side. Here we go. These will cancel. That leaves me x equals 5 plus 4.5. You can do these even though it's a decimal. 9.5. Let's plug it back in though, just to be sure. 9.5 minus 4.5. Yes, that would be 5. We got that right. Last page. Uh-oh. Some people start to panic right about now when they see a fraction. Think way back to Math 4, but I bet you can do a problem with a fraction, so try it. X minus 7/5 equals 11/5. Well, the first step is to notice which operation you have. And here it is. I have subtraction. So then what do I do? Take the opposite. Remember, addition and subtraction are paired up together, so just add. That's the opposite operation of subtraction. But what do I add? I could pick 7, 5, 11, or 5, or pick the whole fraction. Well, if the goal is to keep x by itself, then you're going to need to pick this whole fraction here. You're going to add 7/5 to each side. You're taking the whole term over here. All right, if I have a negative or I'm subtracting 7/5 here, and then I'm adding 7/5 here, these are just going to cancel out. I'm left with x by itself on the left of my equal sign. And I'm going to write this part out here. I have 11/5 plus 7/5. So think back to Math 4 now. How do you add fractions? Luckily for us, the denominators match. They are the same. If that's the case, you keep the denominator the same, and then you just add the top numbers here. 11 plus 7. That would be 18/5. And that is the answer, but you could simplify it. Again, thinking back to Math 4, how do you simplify an improper fraction? Ask yourself, how many times does 5 go into 18 completely? 5, 10, 15. So it goes in 3 times completely. Big number there is 3, because 3 times 5 is 15. And then what's left? 16, 17, 18. 3 remain. And keep the same denominator. 3 3/5 would be a great answer for this question. So do you always have to use x as the variable? No. You can use any letter that you want. You could use your variable y, n, or any of the variables we listed on the first page. In fact, you can even use a symbol. Here's just a problem that I made up. Can you solve it? 8 plus smiley face equals 11. Just do it in your head first. Okay, 8 plus some number equals 11. If I'm going to balance the left side and the right side, then I know that this is going to be 3, right? And if you wanted to, you could say, wait a second, I'm used to seeing my variable on the left side over here. Why did she put the 8 first? You can actually switch these. If you're on one side of the equation, you can just switch these around. So you could rewrite it like this. Smiley face plus 8 equals 11. As long as you're staying on one side of the equation, you can move the terms like that. But just be aware, you can't move the terms back and forth across the equal sign. The equal sign is a hard and fast rule. Don't go across it unless you're balancing by doing the same thing to each side. Okay, so 8 plus smiley face is the same thing as smiley face plus 8. And that's how you're used to seeing it. You look here and you say, I have addition. Do the opposite. Subtract 8 from each side. I can cancel these out. I'm left with smiley face on the left side of the equal sign by itself. 11 minus 8 is 3. So can you make up your own algebra problem using any variable you wish? So this might be kind of interesting. Make up a problem here and then see if your husband, wife, or kid or friend can solve it for you. And I was just thinking, what would I choose to use as my symbol? I've just been looking at some flowers this morning outside my house, so I'm just going to use a flower. How about a tulip? Maybe you have better artistic skills than me, and you can make something very beautiful here, but this is good for now. How about a tulip minus 12 equals 50? There. So you can go ahead and solve that, and I guess I could tell you the answer. Pause the video if you don't want to hear the answer. But the answer to my problem is going to be 62. Very good.